Let's take a look at the practice questions for alkenes. So question 1 is write the IUPAC names for these alkenes. For part A, let's first look at how many carbon atoms there are. We can see that there are actually a total of 5 carbon atoms. So for 5 carbon atoms, the prefix is pent. And since this is an alkene, the suffix will be -ine. For alkenes, we also need to indicate where is the position of the double bond. Okay, so the double bond is here. Let's try to give the double bond the lowest possible number. So let's number it from the left to the right. Then you will get the lowest possible number. So this would be carbon 1, 2, 3, 4, and 5. Since the double bond starts on carbon 2, we can indicate this by calling this 2-pentene. Or we can put the 2 in the middle to say pent-2-ene. Now let's take a look at part B. This question is pretty similar to part A. Here again we have 5 carbon atoms, so the prefix will be pent. Again, this is an alkene with a double bond, so we have the suffix -ine. So once again, we try to number the carbon atoms to give the double bond the lowest possible number. So let's start from the left. 1, 2, 3, 4, 5. And so the carbon double bond starts at carbon number 1, and we will indicate this by saying that this is 1-pentene, or we could say that this is pent-1-ene. Now let's look at question C. In question C, the alkene has a branch chain. So for branch chain alkenes, we will first try to find the longest possible carbon chain. And we can see that the longest carbon chain consists of 5 carbon atoms, which is this chain. The prefix for this parent chain is pent, since it has 5 carbon atoms. And since it's an alkene, the suffix is -ine. We also want to indicate the position of the carbon-carbon double bond, and we must number the carbon chains to give the double bond the lowest possible number. So we will start numbering from the left because that will give it the lowest possible number. So we have 1, 2, 3, 4, and 5, and we can see that the carbon-carbon double bond starts on carbon 2. So we can indicate this by saying 2-pentene or pent-2-ene. Okay, let's follow the more modern way of naming, which is pent-2-ene. Now let's also write the name of the substituent. So this is a methyl substituent, and it is located on carbon number 4. So this would be 4-methyl. So joining the words together, we have 4-methyl pent-2-ene. Now let's take a look at question D. Question D is also a branch alkene. So again, we need to first find the longest chain that contains the carbon-carbon double bond. Okay, we can see that the longest chain contains 6 carbon atoms, and we want to number the carbon atoms in such a way as to give the carbon-carbon double bond the lowest possible number. So let's number from the left to the right. Carbon 1, 2, 3, 4, 5, and 6. Since there are 6 carbon atoms in the parent chain, the prefix would be hex. And since it's an alkene, the suffix will be -ine. Again, we want to indicate where is the double bond. So the double bond starts at carbon 2, and let's write it here, hex-2-ene. Now let's name the substituents. The methyl group is on the second position, so this is called 2-methyl. The chloro group is on carbon number 4. So this is 4-chloro. So to put this all together, remember to name the substituents alphabetically. So since chloro starts with C and methyl starts with M, we will put chloro before methyl. So let's write 4-chloro first, then 2-methyl, and then we'll write the name of the parent chain, which is hex-2-ene. Now let's take a look at practice questions 2. So now we are looking at completing the reaction equations. For part A, we have an alkene, which is propene, reacting with chlorine. So I hope you recognize that this is an addition reaction, where the double bond will be broken and chlorine will be added across the double bond. In case you're not very familiar with skeletal structures yet, let's try out with the full structural formula of propene. This is the full structural formula for propene. When chlorine is added to it, the carbon-carbon double bond will be broken, and the carbon atoms will form new bonds with chlorine atoms. So this is the structure that is formed, and if you want to write out the skeletal structure, you can represent the 3 carbon atoms like this and add on the chlorine atoms. Now let's look at part B. In part B, we have an alkene, which is 2-butene, and this reacts with H2O. So this is another addition reaction where water is being added across the double bond. So again, let's start off with the structural formula for 2-butene. In an addition reaction, the double bond will be broken. And new bonds will be formed between carbon and the atoms from H2O. So H2O is actually H, O, and H. So one of the OH bonds will be broken to form H and OH. And so one of the carbon atoms will form a new bond with hydrogen, another carbon atom will form a new bond with hydroxide or OH. So to write the skeletal structure of this product, we see that there are 4 carbon atoms, so we can write it this way. And we can write the OH in. Now let's look at practice questions 2, number 2. Write the formula of the polymers that are formed from the following monomers. Here we can see that we are starting off with alkenes as the monomers. So when they add to each other to form polymers, the double bond will be broken, and each carbon atom that originally was part of the double bond will form new bonds with other monomers. So for example, for part A, the double bond will be broken, and each carbon atom will form new bonds with other monomers. So to represent this as a polymer, we would first write the atoms in this format. Then we will show that the carbon atoms are forming bonds with other monomers to form that long polymer. And since this is a repeating unit, we will not draw this multiple times, but we will put it in a bracket and write N to represent that there will be many repeating units of this section. So similarly for question B, the double bond between the two carbon atoms will be broken, and each carbon atom will form bonds with surrounding monomers to form a long polymer chain. So to represent the polymer chain, again, we would arrange the atoms in this way. And then we will write that the carbon atoms are forming bonds with other monomers and put this in a bracket with the letter N. So this represents that this is a repeating unit which will be repeated multiple times in the whole polymer.